Algebraic division by Ronnie. Dun, 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 dun. X to the 4. Basically, my main piece of advice here is don't go too fast because there's numbers involved. And my second piece of advice is check your answer. I'm going to write it here to remind us to check because there's just too many, it's too fiddly, isn't it? So what do? We take the biggest part of the numerator and we divide it by the biggest part of the denominator. So we do x to the 4, I'll do it here, over x squared, and we get x squared. Now that is the very first term of our remainder. So all the things that are going to pop out here is our remainder. I don't like putting them across the top. I don't know why. Don't know. I just put them down here. I think it's because I like expanding it out next to where it is. So now, what do we do now? We expand out x squared multiplied by all of this. So x squared times x squared plus x minus 6. And we're going to put everything very clearly under the right place. Very few students are good at lining this up. So I'm just going to put some pencil marks on. And we're going to use each of these columns nice and carefully for each bit. So numbers, x's, squareds, cubes to the 4s. Okay. Right. X squared times x squared, x to the 4. X squared times x, x cubed. X squared times minus 6, minus 6x squared. Done. Subtract. When you subtract, think really clearly to yourself. X to the 4 minus x to the 4. That is 0. X cubed minus x cubed. 0. Minus 3x squared minus 6x squared makes a plus, so 3x squared. And then we've got 7x minus 0, minus 6 minus 0, so they just stay the same. Done. Okay, now we repeat. So what is the biggest thing left in our numerator? 3x squared. So we divide that by the biggest thing in our denominator, which is always x squared, and we get 3x squared. Over x squared, we get 3, and that's the next part of our quotient. We multiply that out by the denominator, giving us 3x squared plus 3x minus 18. And we subtract. We are doing 3x squared minus 3x squared, which gives nothing, and we are doing 7x minus 3x, which gives us 4x, and we are doing minus 6 minus minus 18, which makes it a plus, which makes it a 12. Okay? Now, we can't go any further because the biggest part of our numerator is now smaller than the biggest part of our denominator. So we can't do 4x over x squared, so that's the end. Okay. Now, very, 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 very important. Let's write down what we think we've found. We think that this divided by this is the same as this with a remainder of this still over this. Okay, now it's not quite what we wanted, but you can see that there's some factorising that can go on here, and that's going to get us what we want. So this is x squared plus 3 plus 4x plus 3 over x plus 3, x minus 2. These factors cancel, and we get the form that was required in the question. Hooray! Right, let's go ahead and do our normal. Differentiate the curve. Here's the curve written quite nicely. I'm just going to use this form to differentiate. I'm going to think of this as being that, so that I can use the chain rule. Okay, sub in x is 3. Gives us 2. 6 minus 4 is 2. Negative reciprocal is the reciprocal of the gradient of the tangent. Negative reciprocal of the gradient of the tangent. And then we're going to find the y coordinate. Oh, where's that function? Here it is. There, that's the function, isn't it? X squared, so 3 squared plus 3 plus 4 over 3 minus 2, which is, what's that, 16. 16, 9, 10 and 12, plus 4, 16, yeah. So now we can sub everything into the line equation. Y minus y1 is m x minus x1. Done. That is the end. Okay. It didn't tell us we have to put it in a certain form, so that is the equation of the normal, unless I've done something wrong, which I don't think I have, in which case we are done.